Okay, so we're going to move to a new topic here, moving graphs around. So we want to talk about if you have a graph, y equals f of x, you have the graph of the function. We want to know if you change the formula of the function, how does that change the graph? And so we're going to talk about moving graphs up and down, left and right, stretching and shrinking, up and down and left and right, and reflections up and down, left and right. So every function has a graph and a formula, and we want to be able to connect the two a little bit. So here's a table about what we want to do. Addition, subtraction, multiplication by a positive number, multiplication by -1. What does that do to the function? Well, it depends on whether it's inside the function or outside the function. And remember that y equals f of x is our notation. Inside means inside those parentheses, and outside is outside of the parentheses. And inside always moves left to right, left to right, stretching or shrinking, flipping in the x direction. So inside means tinkering with x. Outside means tinkering with y, doing things up and down in the vertical direction. And this is a graph that I'll be using for the examples. It's got 3 points. Point A is, at -2, 0. B is at 1, 3, and C is at 2, -1. And the graph is a piecewise defined graph, piecewise defined function. You can tell that it's a function because it passes the vertical line test. And there's two parts. One is this line, and then one is that line. We're not going to need the formula for this function. We just need to know that it is a function. And so this is a function, y equals f of x. Okay. So we'll start with moving graphs up and down and left and right. So here's a function, y equals f of x. What's y equals f of x plus 3, and what's the effect of the plus 3? We will see that this moves the graph up 3 units, and that's because it's a plus 3 is that why it's going to move up. So there's a graph. We can set up a little table of inputs and outputs. When x is -2, then y is 0. When x is 1, y is 3. And then when x is 2, y is -1. And those are 3 points. So we're adding 3 outside of the function. What's that going to do to the graph? Well, we take our x value, we run it through the function, that gives us 0, and then we add 3 to the output. So that makes that 3, that makes this 6, that makes this 2. So what we've done then is we have just added 3 to the y values, and the points we want to graph have these as their x coordinates and these as the y coordinates. So at -2, we want a point that's at height 3. That's our new point. At 1, we want a point that's at height 6. And at 2, we want a point that's at height 2. So this is our new A, our new B, we'll call that B prime, and our new C, C prime. And so the graph looks like that. And all it did, right, the plus 3 is it just moved everything up 3 units because we added 3 to each y value, and that moves up 3 units. -5 outside of the function means that we're going to subtract 5 from each y value, and that's just going to push the graph down by 5. So what about f of x -3? The -3 here is actually going to move the graph right 3 units. It's inside the function, which means that it's going to move the graph left or right, because we're going to be tinkering with x. But why is it right 3 units, not left 3 units? So here's our 3 points again, A, B, and C. We know that if our x -3, we want f of x -3. If our x -3 is -2, right? What do you get when you plug -2 into this function? Well, from the graph, you know that -2 plugged into the function gives you 0. And what do you get when you plug 1 into the function? Well, you get 3, because that's the point B. And if you plug in 2, you get -1. But That's not our x values, that's our x minus 3 values, right? If x minus 3 is minus 2, then f of minus 2, that's going to give me the 0. So what's x? If x minus 3 is minus 2, what's x? I have to add 3 to the minus 2, and that gives me 1. If x minus 3 is 1, what is x? Well, add 3 to the 1, and that gives you 4. 4 minus 3 is 1. And then if I have x minus 3 equals to 2, that means x has to be 5. So f of x minus 3 means I take the point x equals 1, I take the x value 1, I subtract 3 from it, and then I look on the graph where it should be, and that should be 0. And my x's are 4 and y is 3, so 4 and 3. So if I want to calculate f of x minus 3 with x equals 4, that means take 4, subtract 3 to it, that's 1, and that gives you this y value. And then c should be 5 comma minus 1. There's my new a prime, b prime, and c prime. So we move the graph right 4 units, because to get x minus 3, actually we moved to right 3 units. To get x minus 3, we have to add 3 to our x values. So there's that function. F of x plus 2 moves left 2 units. So addition and subtraction, if you're doing addition and subtraction outside of the function, it moves it up or down. If you're doing addition and subtraction inside, it moves it left if you're positive and right if it's negative. I think I got, no, that's right. F of x minus 3 moves it right units, f of x plus 2 moves it left. Okay, stretching and contracting. Here's a graph. And we're going to take the graph and we're going to multiply by 2 outside. We're going to see that it stretches by 2 vertically. And what's it going to do is actually multiply the distance a point is away from the x-axis by 2. So here's a little table. Again, the point A is minus 2, 0. B is 1, 3. And then C is 2, minus 1. So if x is minus 2, then f of x, f of minus 2 is 0. And then we want to take that and multiply by 2. So we're taking minus 2, we're plugging into the function, and then we're multiplying the output of the function by 2. So 2 times 0 is 0, 2 times 3 is 6, 2 times minus 1 is minus 2. So we just took the y values and you multiplied them by 2. If your y value is 0, nothing happens, right? So this point doesn't move because it's on the x-axis. This point also doesn't move, whatever point that is, because it's on the x-axis, its y coordinate is 0. The y coordinate for B is 3. That means it's 3 units above the x-axis. If you multiply that height by 2, that stretches it out to 6 units above the x-axis. C is 1 unit below the x-axis. If you multiply that by 2, it moves it to 2 units below the x-axis. So our graph looks like that. So it stretches everything away from the x-axis by a factor of 2. So this is going to take the y values 1/2 f of x and you take your y values and cut them in half. And so if we took 1/2 instead, what that would do, well, it wouldn't do anything to this. It would take b down to here and c down to here. So multiplying by 1/2 actually stretches it, compresses it, shrinks it, whatever word you want, down towards the x-axis. So bigger than 1, you stretch it away. Smaller than 1, you compress it. Okay, what's f of 3x? Now this is inside, right? So this is going to move it left to right. And what's it going to do? It's actually going to shrink to y-axis. by a factor of 3. And again, we have to sort of think about what's going on here. We're going to take our x values and then multiply them by 3 and then run them through the function. And what we know about the function is that if we end up, we take an x value and we multiply by 3 and we get -2, you plug that into the function, -2 gives you 0. What's the x value that when you multiply by 3 gives you -2? Well, that would be, the original x is -2/3. So the point that we want to plot, the new a prime, is going to be -2/3, 0. So that's here. Right? So if we take a prime, which is -2/3, you multiply it by 3, that takes it out to -2, and then you plug into the function, that gives you out the 0. So that's that point. Again, now, if 3x is 1, then we know that the output from the function is 3. But if 3x is 1, what's x? That means 1/3. So we're going to plot the point 1/3, 3. 1/3 is about here, so that's there. And that's going to be our new b prime. And c prime, same kind of thing. If we want 3x to be 2, then x must have been 2/3, and the output is going to be -1. So 2/3 is about here, and then -1. So our graph ends up looking like that. Or c prime. It squished it into towards the y-axis, because you have to take your x's and then multiply by 3 and then insert it into the function. If we know that -2, the function gives you 0, well, that says, well, what is 3x? Has to be -2. So you have to divide by 3, which is shrinking towards the y-axis to get the new points. Okay. 1/4 x, well, if we took 1/4 x, that's going to just expand everything out by 4. So if we take the point, say, let's see, we start with x equals 4, and then we take 1/4 x, that would be 1. And then if we run 1/4 of x through the function, you get f of 1. But f of 1 we know is 3. That means we would have 3 out here. That would be my b value. A would be way out at -8. And then c would be way out at +8. Something like that. So multiplying by 1/4 of x, that would expand, stretch away from y-axis. So again, outside the function stretches it vertically up and down away from the x-axis. Inside the function either contracts it towards the y-axis or away from the y-axis. Okay, and the last thing we want to do is reflections. What does the minus sign do? Again, outside the function, so it's going to be vertical, and this is going to flip over x-axis. So here's our table, right? At -2, we have 0, at B1 was 3, C2 is -1. We take these outputs and we multiply them by -1, we get 0, and then -3 and +1. So we're just changing the signs on the y's. So we plot these x coordinates with these y coordinates. A stays the same, B just flips, it's got a y value now of -3, and C has y value of 1. So there's our new point B prime, C prime, and A prime, and there's our graph. F of -x, this is inside the function. This will just flip it over the y-axis, right? Because it's going to flip it left and right because it's inside the function. So what do we get that? If -x is -2, then f of a is 0, 3, and -1. Those are the usual numbers for A, B, and C. But if minus x is minus 2, what does x have to be? It has to be 2. If minus x is 1, then x is minus 1. If minus x is 2, then this is minus 2. So we end up with that point, this point, and that point. So the minus sign inside the function flips it over the y-axis. This is my new a prime, b prime. Okay, so outside reflects it over the x-axis, inside reflects it over the y-axis. So there's three things we can do, and we can do it either to the x or the y. We can add or subtract, multiply or divide, and we can multiply by minus 1. Adding and subtract just picks up the graph and moves it. Inside moves it left and right, outside moves it up and down. Multiplying by a constant, a positive constant, either stretches it or contracts it. If it's outside the graph, it stretches it up and down. If it's inside the graph, it stretches it left and right. Multiplying by minus 1 reflects it over an axis. Outside, it reflects it over the y-axis. Inside, it flips it. Outside, it flips it over the x-axis. Inside, flips it left and right, so over the y-axis. So here's a function, y equals f of x, and we want to draw the graph of this whole thing. So I'll write that down again. Right, and so it's a graph that's been moved around. We want to know how to move it around. The order to take these things in is very similar to PEMDAS, the order of operations. So start inside, and you do multiplication first, then addition, and inside is inside the parentheses. And then you go outside, and you do multiplication first, and then addition. So subtract by 2. That means we move right 2 units. That's the first thing we do. Then we go, that's the only thing that's happening inside. Outside, we've got a multiplication here and then an addition. So the minus 1/2, it's outside, so it's going to squeeze it towards the x-axis, squeezes it vertically by 1/2, and flips over the x-axis. Right? That's the minus sign. And then finally, the +3 just moves the whole thing up. So we have an order in which we want to do this. First, you move right 2 units, then you flip it and contract it, and then you move it up 3 units. Now, the easiest way to go about figuring out how this looks is to start with your various points, right? A is a special point. It starts at -4,3. What does it do? Well, move it right 2 units. Moving right means changing the x coordinate, and moving it right 2 units means add 2 to the x coordinate. So 2 plus -4 is -2, 3. Now we're moving outside, right? And outside means we're tinkering with the y coordinate, not the x coordinate. So we want to take your y coordinate multiplied by -1/2. So that gives you -2, and -1/2 times 3 is -1.5. And then finally, moving up 3 units means add 3 to the y coordinate. And so -2, and the 3 plus -1.5 is 1.5. So -2, 1.5. That's my new a prime. That's where a moves to. What about b? B starts at -2, 1. What do we do here? Add 2 to the, because we're moving right 2 units, we add 2 to the x coordinate. That'll move it to 0, 1. Multiply the y coordinate by -1/2, because that's outside. And that's -0.5. And then we add 3 to the y coordinate, and that will move us to 2.5. So b goes from 0 to 2.5. There's my new b prime. What does C do? C goes, well, C starts at 2, 2. And then we add 2 units to it to get 4 to the x coordinate. And now we're outside the function, so we're going to multiply it by minus 1/2. Minus 1/2 times the y coordinate is minus 1. And then we're going to add 3 to the y coordinate to move it up. So C goes to 4, 2. And clearly I didn't leave enough space for wherever D is going to end up. And D starts out at 4 minus 1. Move right 2 units, so that's adding 2 to the x coordinate. Minus 1/2 times the y coordinate. Oh, this should be a minus 1 still. Makes that 6, and then minus 1/2 times minus 1 is 0.5. And then we add 3. So 6 would be, say, out here, and then 3.5 would be way up here. So D prime is up there. So what's my new graph look like? Well, now we just connect everything with lines because it was a linear graph to start with. And there's the new graph. So formula written like this is a set of directions. You start with the initial graph, start on the inside, do multiplication first and then addition, figure out what that does. Anything inside changes the x coordinate, but not the y coordinate. And then you look at outside, multiplication, addition. Anything outside changes the y coordinate, but not the x coordinate. Okay, so